This is an example of frictional force. So we're going to look and see how these equations work for kinetic frictional force and static frictional force. So in this case, I have some flat surface here, and I have something that has a mass of 60 kilograms sitting on that surface. The coefficient of static friction for this surface, this interface here, is 0.22. These are dimensionless numbers. The coefficient for kinetic friction between those same two surfaces, I said, is 0.15. So as we start applying a force, I want to look at what's happening. All right? So Fk is mu k n. So that is 0.15 times n. What is n? Well, if I draw a free body diagram, there's mg and there's n. There's an applied force and there's a frictional force. So all four of those. The sum of forces in the vertical direction here, we've got normal force one direction, gravitational force the other direction. So if I add those two together, I should get 0 because it's not accelerating up or down. So the sum of forces in the vertical direction should be 0. So the normal force should be mg. So n is mg. So m, 60 kilograms, g, 9.8 meters per second squared. So Fk is 88.2 newtons. Then the Fs, the static frictional force, is mu Sn. It's less than or equal to that. So that means the maximum possible static force is equal to mu Sn. That I can calculate. So Fs maximum is 0.22 times 60 kg times 9.8 meters per second squared, 129 newtons. So that's the maximum static force. This is the kinetic force of friction. So what does that mean? We've got an F applied here. So if I've got an object sitting on a surface and I apply a force to it, if I apply a very small amount of force, it's not moving. Right? If I apply no force, it's not moving. If I apply a small force, it's still not moving. As I apply more and more force, okay, now it starts to move. So what you have to do is you have to apply enough force to get it to start moving. In this case, that would be this maximum static force. So it won't move at all until you apply this much force to it. Once you apply that much force, now it will start to move, and suddenly we start to use the other one. So the kinetic force of friction. So what happens is, initially, if I make a plot here of applied force and the force of friction. So if I apply 0 force to it, what is the frictional force on this? Force needs a direction, right? And there's nothing trying to move this block any direction. So there actually is no frictional force. That may seem strange because you know if I try to push it, the friction will push back. But if there's nothing trying to move it, there is 0 frictional force. So it starts out at 0. And as I try and push it harder and harder, if it's not moving, that means the frictional force fighting me has to be exactly equal to, so equal to and opposite, the force that I apply. So it goes like this. Slope equal to 1. So if I apply 100 newtons, then the frictional force will be 100 newtons. That will continue to go up and up until I hit that Fs max. As soon as I hit that Fs max, then it will start to slide. And once it starts to slide, now it's kinetic friction. So it will suddenly drop to some other value that no longer depends on how much force I apply. No matter how much I apply, it will continue to have this same Fk. So if I apply 0 force to it, there's zero frictional force. The more force I apply, the more friction there is until I hit the maximum and it starts to move. Then, no matter how much more force I add, it will always have the same kinetic frictional force that it's fighting back with.